Hi class, so here is a video on simplifying radicals that have variables inside of them. Okay, so the process here, there's different ways you can do it, but I want to show you the best way to do it, which is to take your exponent, okay, and then divide it by 2. Let me explain why I divided by 2, because a square root has a 2 right there. Okay, this one as well, it has a 2. Now we don't usually write it, but it's there, and that's the number I'm dividing it by. The first one is kind of simple because whenever you take the square root of a square, this just ends up being x to the first power, because 2 divided by 2 is 1, and that's that. But let me show you what happens here. So when you do have a coefficient, let's go ahead and split this up real quick. We're going to say square root of 9. We'll deal with that times square root of k to the 10. So that's always going to be my first step. We're going to split it. And then square root of 9, that just ends up being 3, because 9 is a perfect square, so that ends up being 3. Whether you know it or not, k to the 10th power is also a perfect square. How? Well, we can think of k to the 10th as just saying, for example, 9. We can think of 9 as being a perfect square because that's the same as 3 squared. Okay, so this ends up being 3. How can I rate k to the 10th power as a perfect square? Well, I can say k to the 10th power is the same as k to the 5th power squared, because 5 times 2 gives you your 10 back. And there's your perfect square. Then when you try to take the square root of it, for example, I take the square root of that cancels out, and I just have my 3. Here, same thing as well. If I want to take the square root of it, the 2 gets canceled out, and then I just have k to the 5th power. This ends up being k to the 5th power. So my final answer is just going to be 3k to the 5th power. Again, that's a bit of an explanation on why this works, but the process, if you want to know just how to do this problem, well, then just take your exponent right here and then divide it by 2 because it's a square root. So 10 divided by 2 gives you your 5. Okay? So let's see, where's another perfect square? Now, any exponent that's an even exponent, for example, 2, 4, 6, 8, 10, 12, those are even. So those work out pretty easy. But if you have an odd exponent, they're a little bit more different. So let me show you how to work with the odd exponent. So what I'm going to do is I'm going to go ahead and take this radical. I'm going to split it again. I'm going to say that this is the same thing as we're going to split it between the perfect squares. This perfect square, I'm going to give the number that's even, n to the 4th power times n. Now this expression is equivalent because 4 plus 1 gives you your 5 back. But the good part is this is a perfect square. So then what I can do now here is I can do 4 divided by that 2 right there. That's hidden, but we don't write it. So 4 divided by 2 is 2. So that's n squared. It comes out of my radical. And then this part, there's nothing I can do about it, so I'm just going to bring it down. And that is how I simplify this part. Okay? Alright, so I'm going to come back to problem number 4. Let's go ahead and do problem number 5 because I like 25. It's a perfect square, but the same process. So I'm going to say square root of 25. Okay, I'm going to just split this all up. I'm going to break it apart. X to the 6th, that's an even number, so that might be pretty easy. And then this one right here, I'm going to say y to the 12th power, because 12 is an even number and is divisible by 2, times y to the 1st power, just y. Alright, let's simplify them. Square root of 25 is 5, because 25 is a perfect square. This one as well, times x to the, so basically what I'm going to do is 6 divided by that 2 that's over here. Again, you don't have to write it, but I just wrote it just to show you. So 6 divided by 2, which is 3, okay, times 12 divided by that 2 that's there. So that's 12 divided by 2 is 6. And then there's nothing I can do, so I'm just going to bring that down. We're going to rewrite this a little better. So the numbers on the outside of my radical just kind of end up variables, put them together. So my answer is going to be 5x to the third, y to the sixth, and then the radical y. That's going to be my answer. Okay. Let's go back to problem number 4 now. So for problem number 4, I'm going to start by splitting this up. So square root of 40 is not a perfect square, right? Because if I do square root of 40, it's not a perfect square, whereas square root of 25 was a perfect square. So what do I do with this 40? Well, I'm going to try to split this up to have a perfect square underneath. So square root of 4 times square root of 10. See how they're equivalent? Which means that I can go ahead and use the square root of 4 times square root of 10. And 10, there's nothing else inside of 10 that I can take out, because 10 is just 5 times 2. It doesn't really work. But square root of 4 is 2. So I can go ahead and rewrite this part as square root of 4 times square root of 10. Didn't change anything there. So here, I'm going to say square root of a to the 18th power, because 18 is divisible by 2, times square root of a. 18 plus 1 is 19. Alright, so this ends up being a perfect square, so that's just 2. It goes on the outside. This doesn't, so that just stays in the inside of my radical. Let me put the perfect squares together first. So this one's going to be 18 divided by that 2 that's right there. 18 divided by 2 is 9, so that's a to the 9th power. And then there's nothing I can do here, so I'm just going to rewrite it as 10a. And that's that. Okay? All right. One last example I have here. So I'm going to rewrite the perfect square here. So I'm going to say p to the 14th times p, square root of p I should say, times square root of q to the 8 times square root of q, and then times square root of r. So that's 14 divided by 2 is 7, so p to the 7th power, and then 8 divided by 2 is 4, so q to the 4th power. So I finished all my perfect squares, and then I'm going to put the rest of them together. So I'm just going to say p, this q, and then this r. There you go.